what is the role of posterior visual area for consciousness? Posterior visual cortical areas, in short, is responsible for phenomenal conscious visual experience. If you lose it, then people, in some case, becomes blindsight, and sometimes they just become blind. And it depends on the exact type of the lesion and so on. But the blind side is the one that I'm going to focus on today. Okay. The blind side patients show striking dissociation of the phenomenology and the behavior. So let's see what it means. Okay. So simple visual tests are called perimetry, like showing some kind of flash of the light, and then just ask subjects, say, oh, I saw the light, and so on and so on. Then we can map where we can see the world. That's called the visual field. Okay. And here's the two patients who has a damage in the brain. But in the case of the neurological paper, it's kind of confusing, but they tend to flip the light on left because they want to see the brain from here, bottom. For the easy comparison, I just flipped the image. So now if you focus on the bottom, then it's clear that this patient, the GY, who shows up a lot for the rest of the lecture, has an damage here on the left hemisphere. And the HK has a damage in the right hemisphere. Okay. And then as a result, GY has a deficit in right side of the visual field. So left side of the brain is responsible for the right side of the visual field, what you see on the right side of what you're seeing. And the HK doesn't have anything on the left side. Okay, so that's the blindness defined by this perimetry test. That's a very important first thing to establish. All right. Now, the interesting thing comes from here. And by the way, this kind of lesion can happen on both areas of both sides of the brain. So in the case of patient TN, he had a really massive, brain lesion here on both sides of the brain, as you can see here. And this is described in one paper in 2008 in Current Biology. And this patient is also part of the blind side patient. So without explaining much, let's observe what the behaviors of these patients are like, or in the case of the monkey whose brains are damaged in particular way. So here, this person, you see, is the TN, and he's now, he usually don't walk around by himself, but in this particular experiment, he was asked by the experimenter to walk this long corridor, and he was reluctantly agreed to challenge to basically say yes on this challenge, and then let's see how it goes. So just behind him, there's a trusted experimenter who convinced him to do this, and then TN, see, he started to avoid this obstacle, and again, although he says he doesn't see anything, and this thin object as well, and even he avoided stepping on something located at the foot. And it was quite surprising even to him. And that's the sort of the typical behaviors of the blind side. Even though they don't do that spontaneously usually, they show the behaviors when they are suggested or forced to do so. And similar kind of behavior has been already reported by monkeys for a long time ago. And here's the interesting video taken by Humphrey for a long time ago. And this monkey, when he also has a lot of lesions in the visual cortex, and initially they didn't understand why this can be possible, because this monkey was supposed to be devoid of the visual cortex, but he was able to move. So these two videos show the behaviors of the blind side for both monkey and human. And to go into the detail of this phenomenology, first we are going to look at what happens when we present some kind of stimulus to these blind-sided patients, and then ask some kind of reports in each trial. So here, what they did was to ask the participants, patients, to look at the fixation cross here for without moving the eyes, and then pressing the button to go to the next trial. And then only for 180 milliseconds, it's a flash of light. It's too fast to move your eyes. Stimulus appears either this location or this location. And then there are two alternatives given to this patient. And then they are asked to choose either this location or this location. So it's called a two alternative force choice, 2AFC. And after doing that, they also report whether they saw the stimulus or not, verbally. Okay, so this is the combination of the force choice plus verbal report. So what did they find? So first type of the blind-sided patient is categorized as a absolute type blind-sided patient. So this type, the patient HK that I showed as a scan for a couple of slides ago, they basically say, first of all, percentage of the awareness, is absolutely zero for all the trials across all the contrast range of the stimulus, regardless of whether it's very faint, 9% or 99% very thick, black and white. He just says, no, I don't see anything. That's absolute blind sight. Yeah, absolute blind, that's fine, but why it's sight? That's the interesting thing. And they are always above chance. So 50% is chance performance for the 2AFC. However, HK performed slightly above chance for all the contrast, and statistically significant for contrast 46% up to 99%. That's what it shows. Then there are another type of the blind side as well. They are called the relative blind side. And there, again, the chance performance is here. And then when the contrast is very weak, their performance is very bad chance performance. But as the contrast increases, performance of the 2AFC task increases. Okay, and then in this case, GY also says awareness. Yes, I saw it. Sometimes, above chance, above 0%. Here this is 0. And then when it's very low contrast, there is some kind of fluctuation, but almost all the time, no. And then when it's very, very high contrast, like 61% and higher, then he tend to say, yes, I saw it in 60% to 75% of the time. So this GY shows some kind of intermediate awareness depending on some kind of factors that we still don't understand. Admit awareness, sometimes not, but the behavior shows more or less constant increase as a function of the contrast of the stimulus. And this type of the patient is called a relative blind side. In summary, as a first step to introduce blind side patient, what I showed was that after lesions in posterior visual cortex, patient report, first of all, loss of visual consciousness. Okay, so that's a verbal report. And yet patients can move around when they are forced. That's a case of a TN, walking around this corridor, right? But important thing is that patients usually do not move under the spontaneous kind of situation because they don't see it. So consciously they think that they don't have any conscious access to the visual information in the world, and they rely on other senses such as touch or sound. And then lesioned monkeys also seem to move around. By the way, in the video, that's important to say that the patient was put into the situation where he couldn't actually access any kind of sound or other types of the hints, which he usually uses, like using the stick and so on to check whether he has an obstacle or not. Okay, and then lesioned monkeys seem to also be behaving like a blindsight patients. And then now, towards the end, I also showed that one task of the two alternative force choice tasks, where patients' behaviors dissociate from their phenomenal reports. Sometimes they say, I don't see it at all, but their performance steadily increases as a function of the stimulus contrast. And sometimes, they again increase their performance, but in some section they say, no, I don't see it. And sometimes they see sometimes. So that there's a huge dissociation. So that poses us a question. What's it like to be a blindsight patient? And is there any way to know that? That's a question as a consciousness researcher. And one possibility that is relatively easy to imagine is that maybe it's like seeing everything like us, but only very faintly. And that may be able to kind of explain their behavior, right? So for them, it's really very different from their memory of how the vision should be like. And it's so faint that, it's almost invisible, but, you can use the information above chance. But they just say, no, this is very different from my vision. And that kind of hypothesis can be potentially tested in the task. And that's what I'm going to discuss next.